So here in this problem, we need to show the following, provided y is given by x times log of x over a plus bx. So let's begin with whatever we are provided with. So we have y equals to x times log of x divided by a plus bx. We'll divide both sides with x, so that gives us y over x equals to log of, now we have log of x divided by a plus bx, so here we'll use the property of logarithm. That means if we have log of a over b, that's equals to log of a minus log of b. That gives us log of x minus log of a plus bx. Fine. Now what we'll do, we'll take the derivative on both sides with respect to x. So we have derivative with respect to x of y over x equals to derivative with respect to x of log of x minus derivative with respect to x of log of a plus bx. Now to find the derivative of y over x, we will have to use the quotient rule. So we'll start with the denominator, so y of x, so we'll square it. Then in the numerator, again we'll start with the value in the denominator, which is x, and multiply it to the derivative of the numerator, which is y. Minus, we have already took the derivative of y, so we'll keep it aside y and multiply it to derivative of the denominator, which is x. And this will be equals to derivative of logarithmic function, which is simply 1 over x, minus derivative of log of a plus bx, so that will be 1 divided by a plus bx. But we'll also have to use the chain rule and multiply it to derivative with respect to x of a plus bx. That gives us x over x squared, so that will be 1 over x times dy over dx minus y over x squared, because derivative of x with respect to x, so that simply equals to 1. So that will be equals to 1 over x minus the derivative of a plus bx, so that's simply b divided by a plus bx. Further simplifying, so we'll combine the two terms on the right hand side. And that will be equals to, we have x multiplied to a plus bx, and in the numerator we have a plus bx minus bx. So bx and negative bx will get cancelled out, and here we have 1 over x times dy over dx minus y over x squared. Right. That gives us 1 over x times dy over dx minus y over x squared equals to a divided by x times a plus bx. What we're going to do now, we're going to multiply both sides of the equation with x squared. So we're going to multiply x squared to the right hand side as well, and this is going to give us x times dy over dx minus y will be equals to, so here 1x and 1x cancelling out, so we have a times x divided by a plus bx. The reason why we have done this, because if we go to our problem, we will see that we have this particular term x times dy over dx minus y. So we wrote it in this way so that we have this particular expression. We have to further take the derivative because we also have to find out the second derivative. Okay, so we will set it aside for the time being. We will be using this again a little while later from now. Now what we'll do, we'll take the derivative on both sides with respect to x. So let's take the derivative with respect to x of x dy over dx minus y equals to derivative with respect to x of ax divided by a plus bx. Right. So that's where was derivative with respect to x of x times dy over dx minus y, derivative of y with respect to x. And here we'll have to use the quotient rule. We'll start with the denominator. We have a plus bx whole squared. In the numerator, we'll again start with the value of the denominator, which is a plus bx, and multiply it to the derivative of the numerator, which is ax. Since I've already taken the derivative of the numerator, so we'll keep the numerator aside and we will multiply it to the derivative of the denominator, that is a plus bx. So that means we will now have, so here we'll have to use the product rule. So this is going to give us derivative of x with respect to x multiplied to dy over dx plus x times derivative of y with respect to x minus derivative of no, this is second derivative of y with respect to x minus derivative of y with respect to x equals to a plus bx. Derivative of ax with respect to x, so that's simply I, minus ax times derivative of a plus bx will be b. Whole thing divided by a plus bx whole squared. Now derivative of x with respect to x, so that value is equals to 1. So we have dy over dx minus, so this term and this particular term will get cancelled out. And this is going to give us x times second derivative of y with respect to x equals to, let's multiply. So we have a squared plus abx minus abx divided by a plus bx whole squared. So abx and negative abx cancels out. Now that leaves us with x times d squared y over dx squared. We have a squared over a plus bx whole squared, or simply a divided by a plus bx whole squared. Now what we'll do, we'll multiply x squared to both sides. And when doing so, we'll say here we'll have x cubed multiplied to second derivative of y with respect to x. And here x squared, we'll take it inside the parentheses. So we have a times x divided by a plus bx whole squared. Why we have multiplied with x squared? Because we can replace ax divided by a plus bx with this particular expression, which is x times first derivative of y with respect to x minus y. So that means that will be x cubed times first derivative of y with respect to x equals to, so in place of ax plus a plus bx, we can replace it with x times first derivative of y with respect to x minus y whole square. And this was what we were asked to prove.